Assalamu alaikum warahmatullahi wabarakatuh. Welcome back, my friend, to my YouTube channel Abdelaziz Gabr. Today, inshallah, we will talk about very important topic. It's about the deep water drilling. Deep water drilling, actually, why we are talking about deep water drilling? Actually, because this is the most advanced technology now all over the world. It's used mainly in deep water drilling. So we will talk about semi-submersible pump, semi-submersible rig. We will talk about the BOB and its controlling system, which is totally different than the surface one. And we will talk about the drill chips here. Okay. So first of all, our course content, we will take introduction about the importance of the deep water and about its economical effect in last 10 years at least, okay, and about its future promising projects, by the way. Then we will talk about the drill ships and semi-submersible rigs. Why? Because this is the only two rigs that can drill in the deep water. Deep water, actually, it can reach to 300 kilometers of water, or 200 kilometers of water. Sorry, 2 kilometers of water and 3 kilometers of water. So actually, this is very complicated technology, and we have to learn at least some notes about it. Then we will talk about some equipment, which is the main difference between the surface and the deep water drilling. It's called the marine riser, and we will talk about some of its components and their function, which is very important. Then we will talk about IWCF for subsea, which is deep water BOB and its well control system. This is very important and complicated. We will talk about it in deep details. Then after this, we will take some questions about the subsea IWCF. So it will be very helpful, inshallah, for our job, يعني, okay, or for anyone who needs to take the subsea IWCF, okay. So why deep water? Actually, why deep water? Because the future oil demand will remain strong. Actually, there are some countries now which are developing countries, so they need the oil for their industries. So all the time we are under the demand of oil. All the world are depending on oil and the gas industry. So this is very important because it's the main the backbone of any industry or even of our life. So this is very important. So we have to discover more and more potential and more reservoirs all over the world. So now the technology is going to check for the deep water drilling, where a lot of reservoirs, big reservoirs, are still under this deep water, especially in the Middle East and also in the western of Africa. Deep water also is where the remaining big reserves are located. Yes, because the technology before were not able to drill these wells efficiently and economically. But nowadays, by the using of AI technology and other high technology, we can drill these wells in the deep water without any issues. Without any issues about this one, by the way. Deep water here. Deep water will account for almost 25 or almost 25% of global offshore production by 2030, compared to just 15 percentage right now. So this means that the future is mainly for the deep water drilling and its technology. Innovative technologies will allow economic development in deep and ultra deep water. So we will get more and more from this deep water drilling reserves, by the way. Okay. So as you see here, this is the relative deep water well activity from 2013 and 2015. As you see here, the big market was in the deep water for Brazil, Petrobras, about 36 percentage, and then the BB has 10 percentage, and all of us knows about what happened for the BOB in Macondo, well in the Gulf of Mexico, and how it affects its reputation, by the way. Here also Total, it's about 10 percentage, 7 percentage ExxonMobil, and 7 percentage for Shell. And here also Otris about 21, and another companies here. Here this is ENI or ENI, and mainly ENI is its activity is mainly in the Mediterranean Sea, by the way. So as you see, the biggest companies all over the world, the multinational companies, are investing in this new technology for this new drilling techniques, by the way. Okay. So how much does a deep water well cost? Actually, it costs very high, and its cost is very high. But you have to take into account this one important, very important issue. The يعني from COVID and the supply chain all over the world it changes. So the power and the oil and gas where before it were if it was accessible somewhere, but now sometimes it is not accessible, especially due for the war between Russia and Ukraine, so that the gas is not coming, for example, to Europe. So they have to search for another resources like or sources like, for example, what they had got from Norway, and this comes from deep water also, and also some new countries like Angola, like other countries in the west of Africa, and even in the Middle East, in the Mediterranean Sea, we are searching also, and most of the conflict in the Middle East is about taking their share from the gas reserves there. Okay, so here Oklahoma, 3,000 feet, it takes 5 days and only $90,000. Albania, it's about 15,000 feet for 100 days. This is very critical, by the way. I think it's 40, not for 100 days, but it could be 40 days, which is $15 million. Okay, deep water Gulf, it's about 35,000 feet. It takes 60 days with $85 million. But the most expensive well ever was the BB Caspian Sea well over. It's about $240 million, which is very very expensive one until they get yeah, potential. Yeah, okay. So now discoveries and potential discoveries for the future. As you see here, this is the actual and the forecast numbers for the deep producing field by region. As you see here, for example, in 1998 and 2200. For 1998, it was very the technology was not available, by the way. So only 25 or 26 or 28, here it was 28. All those were producing about 28. So 28 and they are discovering about 28, and all of these are discovering them. So here, as you see here, the US share, as you see in the US Gulf, is the most common. Then after it is the Far East, so they have the main technology. Then after sometimes the West Africa here by Angola and Nigeria comes to the same shares after some discoveries in the Atlantic Ocean. So here, as you see, within just 4 years, you can see how the potentials and discoveries increased from 28 to 96, which is almost about uh, 4 times of the activity, by the way. So this is very important. And here the discovered and estimated potential deep water reserves worldwide, billions of barrels or equivalent, about billions of barrels. So as you see here, for example, the like US Gulf, it's about 23. As you see here, Angola in West Africa, it's about 25 million, which is its potential, and it's discovered increased, and also its potential is very high. As you see here also, for Antarctica, okay, or the south pole, yeah, or the southern pole, here as you see this is a large potential, so this means that in the future it could be exploited, or we could make good use of this reserves there, so life can be available in this Antarctica, by the way. Okay, so here these are the billions of barrels of discovered and potential deep water reserves. Okay, so how do they drill in deep water? As I told you, we have here two main types of rigs. Number one is the semi-submersible rig. As you see, this semi-submersible, as you see, it's free. Some of its parts is submersible in the water. So once you finish, you can directly dump this water from evacuate this water from here, so it can become floating, and you can go to another location, by the way. Here this is it can be fixed in its place by tensioners here, and the dynamic fixing system, by the way, here. Okay, so it can be used in deep waters more than 400 feet or more than 120 meter. Large hull made of pontoons supporting large diameter columns that supports a large topside area. That's it. Okay, this is here large hull here are made of pontoons supporting the large diameter column, as you see here, which are supporting the large area on the top side. Okay, it's very stable in rough weather due to the size of the and submerged part, which is usually filled with ballast water to give more stability, as I have informed you. Okay, then they are kept in a location by a set of strong anchors or a dynamic positioning system consists of a set of thrusters and environmental system, or combination of both thrusters and anchors. Okay, so this is used here as a dynamic system, by the way. Okay, so this is the semi-sub, and let's check
are
for
the
it here.
semi-submersible rigs, used in deeper offshore locations where the water depth is usually greater than 400 feet. These large rigs float, are seaworthy, and are very stable in high seas. Semi-submersibles do not sit on the ocean floor like jackups, but are held in location by anchors and thrusters on each of the four corners to keep them dynamically positioned. Semi-submersibles are self-propelled and can operate offshore anywhere in the world. Besides
As you
their
see,
anchors
these
and
are the
thrusters,
systems to keep
another
it in
thing that
place
keeps them very
without
stable
any
during drilling
issues. These are the
is that
thrusters,
parts of the
and
ship can
as
be
you see,
filled with ocean water
this rig
to
can
add
go at
ballast.
any
Thus its name,
place in
semi-submersible.
the ocean.
After
So
drilling
it's
is
very easy
completed,
to
the
move
water in the
from
hull
place
of
to
the
place without
semi-submersible
any
is pumped
need for
out,
any issue, by
and
the way.
then it
Okay,
is
so this is
floated to
very
the next location.
good technology, by the way. Okay. Okay. Now the second type is called the drill ship, and as you see here, this is the drill ship. It's a ship, but it's like the city, by the way. Okay, this is large city. As you see, two masts, which means there is main rig and auxiliary rig, by the way. So it can do double job. Yani it can do two jobs on the same time, by the way. So to prepare for the rig and to do the drilling for the same way. Okay, it's dynamically positioned. Dynamically means this is the system of the dynamic system for positioning it. No anchors required. It can operate in water depths up to 10,000 feet, which is about 3,000 meters, by the way. Okay, mainly used for geological studies and exploration, as they cannot keep other location for a long time, especially in rough sea. This is why, because this is not. That's why it is not. That's why it is not. يعني all the time it's here, as you see. This is in the rough sea, so that's not all the time we used. يعني, so we can use another thing like the submersible, by the way. Okay, so this is a drill ship. And let's check for
Dynamically positioned, drill ships can be used in very deep water where anchoring is extremely
You see it's
difficult,
deeper here.
but where the sea surface is relatively calm. They can be moved rapidly from location to location. Because drill ships may not be able to maintain their position for long periods in rough seas, they are favored for geological studies and for wildcat wells where permanent structures are not yet warranted.
Okay. Also here, they allow production of hydrocarbons in water depths where conventional fixed or bottom founded platform cannot be installed. As you see here, this is a fixed platform for this one, but this is compliant tower, and this is TLP, spar, and this is also subsea completion can be here, which is very complicated technology, by the way. But actually, as you know, this can be also reached. Okay, so what is the meaning of deep water drilling? Actually, API defines the deep water as depths in excess of 2000 feet or 600 meter, and ultra deep water as water depths in excess more than 5000 feet, which is 1500 meters, by the way. So let's see this video about the deep water drilling operation and check it together, by the way. Okay.
How does the deep-sea drilling vessel Chiku drill into the seafloor? When the vessel arrives at the drilling site, it receives a satellite signal that helps the vessel move into the exact position required. The vessel has 6 propellers that rotate a full 360 degrees and keep the vessel in one position, preventing it from drifting due to the wind, waves, or sea current. First, the conductor pipe is installed. As the drill pipes are connected, the conductor pipe and guide are run down to the seafloor. After the conductor pipe penetrates the seafloor, the drill pipe is released and pulled back to the vessel. A large drill bit connected to the bottom of the drill pipe is run down to the seafloor. The drill bit is led down to the bottom of the hole through the conductor pipe. The drill bit rotates and drills the sediment and rock below the seabed. Seawater is sprayed from nozzles on the drill bit to raise the cuttings to the seafloor. After drilling several hundred meters, the drill bit is pulled back to the vessel. A casing pipe, about 50 centimeters in diameter, is set into the drilled hole to keep it from collapsing. The casing pipe is run down through the conductor pipe and is inserted into the hole using the drill pipe. Cement is pumped into the space between the hole and the casing pipe to fix the pipe in place. After cementing, the drill pipe is released and pulled back to the vessel. The Chiku is equipped with the riser system in order to drill into the earth even deeper. As the riser pipes are added one after another, the blowout preventer is run down to the seafloor. The blowout preventer is connected to a wellhead which is located on top of the casing pipe. The vessel is now connected to the seafloor via the riser pipe. A drill bit, smaller than the one first used, is run down through the riser pipe and casing pipe. The drilling begins. Once the riser pipe has been connected, drilling mud is used instead of seawater. When the target depth is reached, the drill bit is pulled back to the vessel. To drill the hole even deeper, a narrower casing pipe is set in to protect the drilled hole. After the casing pipe has been installed, cement is pumped into the space between the hole and the casing pipe to fix the pipe in place. Again, an even smaller drill bit is run down through the riser pipe and casing pipe, and the drilling continues. Repeating this process, the Chiku will drill through the ocean crust to collect fresh, live mantle. This is something that has never been done before.
Okay, this was the first video, and let's check out the rotary system.
Rotary drilling is used for ocean drilling. Let's look at the features of this method. First, the drill pipes are connected one after another as they run down to the seafloor. The work of connecting the drill pipes and drilling the hole are powered by a motor on the derrick. The drill pipe has a drill bit attached to the bottom. With rotary drilling, the drill pipe is rotated and the drill bit at the end crushes sediment and rock to make the hole. After a while, cuttings accumulate at the bottom and drilling cannot go any further. Seawater or other liquid is then pumped from the vessel down through the drill pipe and is jetted out of the nozzles on the drill bit. This liquid current forces the cuttings up to the seafloor. That is rotary drilling. The deep-sea drilling vessel Chiku can drill over 7 kilometers below